Okay, so let's start with the first problem. It says find and classify the equilibrium solutions of the autonomous differential equation y prime equals blah blah blah. Draw a rough sketch showing the behavior of the solutions. Okay, so let's start by finding the equilibrium solutions. Okay, for that, remember that means we have to set up y prime equals 0 and solve. So that means we're going to do y prime equals 0 and we're going to solve what that gives. So this is 0 equals y squared times 4 minus y times y plus 3. Okay, solving that is easy. That means that y could be 0, y could be 4, or y could be negative 3. All right, so those are the equilibrium solutions. Now we're going to draw a sketch with these three equilibrium solutions. So let's see, I'm gonna draw the axis here. This is just a sketch. I don't have a ruler. Um, so 1 is 0, 1 is 4, so let's say this is 0. This is the equilibrium solution y equals 0. And then we have here y equals 4 somewhere over here. Let's say y equals 4. So this is y equals 4. And then somewhere over here we have y equals negative 3. Y equals negative 3. Okay, so those are the three equilibrium solutions. This is also the same as the t-axis, right? T is the independent variable. All right, so now let's plug in numbers between each of these. So if we start above 4, let's say we plug in 5 here, y equals 5. If you plug in y equals 5, we're going to have the derivative is going to be, well, that's positive. If I put 5 here, that is negative, and that's positive. So positive, negative, positive, that gives me negative. So that means for solution in this region, the solutions are going to decrease because the derivative is negative. So maybe they're going to look like this. Right, let me see if I have another. Maybe this is better. Right, so they're going to be decreasing. Now, if you plug in a number between 0 and 4, let's say 1, for example, then this is going to be positive, this is going to be positive, because 4 minus 1 is 3, and then this is positive. So three positives gives you positive, so that means solutions in this area are increasing, they have positive slope. So they might look like this. Right? Now, if you plug in a number between negative 3 and 0, such as, let's say, negative 1, negative 1 squared is going to be positive. 4 minus negative 1 is going to be positive 5, and then negative 1 plus 3 is positive 2. So positive, positive, positive. Solutions in this area are going to be increasing because they're going to have positive slope. And then lastly, for solutions below, I mean in this region right here, if I plug in, let's say, negative 4, I'm going to have positive, and then this is going to be positive 8, so that's positive, and then negative. So positive, positive, negative. So that means solutions in this region are going to decrease. So that would be the rough sketch. And finally, for the classification, this one would be stable, right? Because from both sides, solutions are tending towards the equilibrium solution. From this side, from below, it tends to it. From above, it goes away from it. So this is semi-stable. And lastly, this one, from both sides, solutions go away from it. So this is unstable. right? And that would be it. That is the solution for problem number 1. Okay, now let's solve problem number 2. It says that we have to solve an initial value problem. Okay, that differential equation right there is a differential equation in what's the word? In differential form, right? So let's call this part right here P, and this part right here Q. Okay, and we're gonna check whether this is exact, whether this is an exact differential equation. So start by finding the partial derivative of Q with respect to X. If we find the partial derivative of that with respect to X, that is going to be 2y. And now let's find the partial derivative of P with respect to y. If we find the partial derivative of that with respect to y, that is going to be 2y. So note that these are the same, so therefore the equation is exact because they're the same. Now, if the differential equation is exact, that means, there's a procedure, very specific procedure for solving this. So remember now what is the procedure? We are looking for, so we're looking for a function psi of two variables, right? It's going to be a function of two variables, such that when we compute the partial derivative of psi with respect to x, we get p. So the partial derivative of psi with respect to x is p, which is y squared plus cosine of x. And when you find the partial derivative of psi with respect to y, we get q, which is 2xy plus sine of y. Alright, so our goal is to find a function that satisfies that. And remember, for doing this, this is just a matter of integrating. You can integrate whatever looks easiest to you. You can integrate this one with respect to x or that one with respect to y, and proceed from there. But I'm just gonna choose the second one. I'm gonna integrate the second one with respect to y, so I can undo that partial derivative. So integrating that one with respect to y, right? The integral is gonna undo the partial, so you're gonna get psi equals, and then the integral of that with respect to y is going to be x y squared minus cosine of y, right? The derivative of cosine is negative sign, so negative and negative gives you positive sign. And then, because we're integrating with respect to y, there could have been some expressions here with x that when we take the partial with respect to y, they disappear. So that means there could have been some other stuff here that that had x, like a function of x. So plus g of x for some function g, for some function g. Okay, so that is psi. Now, we're going to use the other equation. This one we haven't used. So now we're going to take the partial derivative with respect to x on both sides and we're going to compare. So on the one hand, when I take the partial derivative of psi with respect to x using this formula, the partial derivative of that with respect to x, so the partial of that with respect to x will be 2xy. Sorry, my bad. The derivative of that with respect to x is y squared. Oops. Y squared. The derivative of that with respect to x is y squared. The derivative of that with respect to x, well, that goes away. And then the derivative of that with respect to x is just g prime of x. So that's the derivative with respect to x on the one hand. On the other hand, I know that it's supposed to be this. So this is supposed to be y squared plus cosine of x. right? And now if you compare, you see that that means that g prime of x has to be cosine of x. So g prime of x has to be cosine of x. And now integrating, that means that g of x, if the derivative of g is cosine of x, that means that g must have been sine of x. And remember that even though we're integrating here, we don't put the plus c because we're just looking for one function g. Uh, the c you added at the end. So that means that's our g. And putting this g back in here, we get our formula for psi. So that means psi is going to be equal to x y squared minus cosine of y plus g of x, but g of x is sine of x. So that is psi. And finally, we know what the general solution is going to be. Always, once you find the psi, the general solution is psi equals capital C, right? So that means the general solution is going to be this equal to capital C. So x y squared minus cosine of y plus sine of x equals capital C. So this is the general solution. Now, this is an initial value problem, so we really need to figure out what is the constant C. And that's what we're going to do now. We're going to figure out what C needs to be. Okay, so the initial condition is that whenever x is pi, y equals pi over 2. So now we're going to use that right here. Now we're going to use that when x equals pi, y equals pi over 2. And we're going to figure out what C needs to be. So plugging that in this equation right here, we're going to get, well, x equals pi, so pi times, and then this one squared, right? So pi over 2 squared is pi squared over 4 minus cosine of pi over 2 plus sine of pi equals C. Now, cosine of pi over 2 is 0. Sine of pi is 0. So that means C equals this. So that means really then that C equals that which is pi over 3, pi to the third over 4. So that means now the particular solution is x y squared minus cosine of y plus sine of x equals C, and C is pi cubed over 4. So that is the solution to the initial value problem. All right? Okay. Okay, now we're going to solve this problem number 3. This is differential equation that is in differential form, and it is not exact, right? So what we have to do is find an integrating factor, meaning find a function such that if you were to use that function to multiply this differential equation by that, then it would become exact, and you could solve it just like we solved problem number 2. But now, because I already tested whether you know how to solve an exact equation, I don't need you to solve this one, right? Because it will be the same. So all I want to do in this problem is just to convert it um, to an exact equation, and that means just find an integrating factor. All right, so let's do it. All right, so again, this is in differential form, so that means let's call this P and let's call that Q, right? So that means P is 2x squared plus y, and Q equals x squared y minus x. All right, now the partial of Q with respect to x equals the derivative of that with respect to x is going to be 2xy minus 1, and then the derivative of p with respect to y, right? If I take the derivative of that with respect to y, that's going to be just 1. So you see they're not the same, so this is not exact. However, when you find the difference, you have to think whether when you find the difference, if you divide by p or if you divide by q, does one of those combinations give you a function of one variable only, right? So you have two possible combinations. You have either um, the partial of p with respect to y minus the partial of q with respect to x. Dividing that by q is a function of only one variable, or the other possibility is partial of q over partial of x minus partial of p partial of y over p. Remember that these two have to match. So when you do this, uh, make sure that they are in the correct order. So you try both of these possibilities and see which one simplifies to a function of only one variable. And in this one, after trying, you realize that the one that works is partial of p with respect to y minus partial of q with respect to x divided by q. And now let's work this out, see what it gives you. So this one is 1 minus partial q with respect to x is 2xy minus 1. All that over q, which is x squared y minus x. Now, simplifying, this is 2 minus 2xy, and the bottom is, you can factor out an x, so xy minus 1. And now, if you factor out a negative 2 from the top, this is going to be xy minus 1 over xy minus 1, which now makes those cancel and gives you negative 2 over x. So you see this is a function of only one variable, a function of x. So then that means the integrating factor, is then going to be mu of x equals e to the integral of this thing, negative 2 over x dx. Now let's do this integral, and once we do this, we're done, right? So this is going to be pulling out the negative 2, this is negative 2 integral of 1 over x dx. Now this is e to the negative 2 ln absolute value of x, right? We don't do a plus c, we're just looking for one function that works. And then this is equal to, you can put the negative 2 inside the parentheses, so this is going to, the ln, so this is going to be e to the ln of absolute value of x to the negative 2. The exponent is even, so you don't really need the absolute values, so this is the same as e to the, well, now the e and the ln cancel each other off, so really this gives you absolute value of x to the negative 2, and as I said, the exponent is even, so you don't really need the absolute values. And most of the time we choose either the positive one or the negative one, so we kind of drop them anyways. So I'm going to say this is the same as 1 over x, right? Which it is. Okay. All right, and that is the integrating factor. That's the answer. That's the integrating factor. Okay.